Every year, farms and food processing facilities generate hundreds of millions of tons of vegetable waste. Leaves, stems, peels, rejected crops, and unsold produce. At first glance, it looks like loss. Piles of discarded greens stretching across fields and factory yards. But here's the truth most people never see. This waste is actually one of the most powerful hidden resources in modern agriculture. In the United States alone, vegetable and food waste exceeds 60 million tons annually. And a growing percentage of it is now captured, processed, and transformed into animal feed, renewable energy, and nutrient-rich soil. Today, we're stepping inside the supergiant vegetable waste recycling industry, where millions of tons of farm leftovers are turned into food, fuel, and fertilizer in a massive circular system. Before we dive in, don't forget to like, subscribe, and turn on the notification bell so you never miss our deep dive documentaries into the industries that quietly power the modern world. The story begins in the fields. Across vast agricultural regions, vegetables are harvested at incredible scale. Lettuce, carrots, broccoli, cabbage, tomatoes, millions of tons are collected every season. But not everything makes it to market. Up to 20 to 30% of harvested vegetables are rejected due to size, shape, cosmetic defects, or overproduction. These imperfect crops are perfectly edible, but they don't meet strict retail standards. At the same time, mechanical harvesting leaves behind large amounts of plant material. Leaves, stems, and roots remain scattered across fields, creating a massive stream of organic residue. In the past, much of this material was plowed back into the soil or simply left to decompose. But today, with growing demand for efficiency and sustainability, this waste is becoming a valuable resource. The journey begins with collection. In large-scale operations, specialized machines move through fields after harvest, gathering leftover plant material. For processing plants, conveyor systems and sorting lines separate edible products from waste streams. Every day, trucks transport tons of vegetable waste from farms, packing houses, and food processing facilities to centralized recycling centers. Some large vegetable processing plants generate hundreds of tons of waste per day, creating a constant flow of raw material. Once the waste arrives at a recycling facility, the first step is sorting and pre-processing. Vegetable waste is highly variable. Some materials are wet and soft, like tomato pulp or lettuce leaves. Others are fibrous, like corn husks or cabbage stems. Machines shred and grind the material into smaller, uniform pieces. This increases surface area and prepares it for further processing. From here, the waste enters multiple transformation pathways. One of the most important is animal feed production. Certain vegetable residues are rich in nutrients and can be safely processed into livestock feed. Carrot tops, beet pulp, and leafy greens are chopped, dried, or fermented to create feed products for cattle, pigs, and other animals. In some facilities, vegetable waste is mixed with grains and other ingredients to create balanced feed formulations. This process alone redirects millions of tons of food waste away from landfills and into productive use. But not all vegetable waste is suitable for feeding animals. That's where energy production comes in. At biogas plants, vegetable waste becomes fuel. The shredded organic material is fed into large, sealed tanks known as anaerobic digesters. Inside, microorganisms break down the waste in the absence of oxygen. As the material decomposes, it releases methane-rich gas. This biogas can be used to generate electricity, heat, or renewable natural gas. A single large digester can process 50,000 to 100,000 tons of organic waste per year, producing enough energy to power thousands of homes. Some advanced facilities upgrade this gas into pipeline-quality fuel, integrating it directly into energy networks. After digestion, what remains is digestate, a nutrient-rich material that is far from waste. Digestate is separated into liquid and solid fractions. The liquid portion is used as fertilizer, delivering essential nutrients like nitrogen, phosphorus, and potassium back to farmland. The solid portion is used as compost or soil conditioner. This completes a powerful loop. Nutrients taken from the soil are returned, supporting future crop growth. Another major pathway is composting. In large composting facilities, vegetable waste is piled into massive windrows, long rows that can stretch for hundreds of meters. These piles are regularly turned to maintain oxygen flow and control temperature. During composting, temperatures can rise above 60 degrees Celsius, killing pathogens and breaking down organic matter. After several weeks to months, the material transforms into rich, dark compost. This compost improves soil structure, increases water retention, and enhances fertility. Across the United States, composting facilities process millions of tons of organic waste annually, much of it from agricultural sources. But the innovation doesn't stop there. Vegetable waste is also being used to create industrial materials. Fibrous residues can be processed into biodegradable packaging, paper products, and even construction materials. In some advanced systems, plant fibers are extracted and used to produce bio-based plastics, materials that can replace petroleum-based plastics in certain applications. Food processing waste is also a source of valuable compounds. Tomato skins can be processed to extract lycopene, a powerful antioxidant. Citrus peels yield essential oils. Potato waste can be converted into starch products. These high-value extracts add another layer of efficiency to the system. Nothing is wasted. The scale of this industry is enormous. Recycling facilities operate continuously, processing hundreds, sometimes thousands, of tons of vegetable waste every day. Conveyor belts, shredders, digesters, and composting systems work together in a coordinated flow. Sensors monitor moisture levels, temperature, gas production, and nutrient content in real time. Automated systems adjust conditions to maximize efficiency and output. This level of control transforms unpredictable waste into a stable and valuable resource. And that is the key to the entire system. What was once considered a disposal problem is now a supply chain. A supply chain that produces feed, energy, and materials. A supply chain that reduces environmental impact. And a supply chain that supports sustainable agriculture. Because when vegetable waste is sent to landfills, it decomposes without oxygen and produces methane, a potent greenhouse gas. By capturing and processing this waste, the industry not only creates value, but also reduces emissions. This makes vegetable waste recycling a critical part of climate solutions. As demand for sustainable systems grows, this industry continues to expand. New technologies are being developed to extract more value from organic waste. Advanced biorefineries are exploring ways to convert plant residues into fuels, chemicals, and high-performance materials. Artificial intelligence is being used to optimize sorting and processing. Automation is increasing efficiency and reducing costs. From farms to factories, the system is becoming more integrated every year, and yet most people never see it. They see fresh vegetables in stores, but not the massive flows of material behind the scenes. They see food, but not the system that ensures nothing goes to waste. In the supergiant vegetable waste recycling industry, millions of tons of plant material are given a second life every year. They feed animals, they power homes, they rebuild soil, and they prove that in the right system, waste is not the end of a process, but the beginning of a new one. If you enjoyed this deep dive into one of the most important hidden industries in the world, make sure to like, subscribe, and hit the notification bell so you never miss our next exploration into the systems that power our modern life. Thanks for watching. And remember, the future isn't just about producing more, it's about wasting less. Every year in America, millions of tons of carrots are pulled from the soil, orange, crisp, and packed with nutrients. This is the supergiant carrot harvest, a story of innovation, machinery, and transformation, where humble roots become crunchy snacks enjoyed by millions. Before we begin, if you love seeing how nature and technology come together in mind-blowing ways, hit that subscribe button and join our journey through the world's most fascinating production lines. Our journey begins in California's Central Valley, the beating heart of carrot production in the United States. Here, the soil is soft, the climate mild, and the land stretches endlessly in perfect rows of vibrant green tops waving in the sun. In this fertile valley, giants like Grimway Farms and Bolthouse Farms have turned farming into a high-tech science. Together, they produce over 85% of all carrots grown in America. That's more than 3 million tons each year. Seeds are planted with GPS-guided seeders, ensuring perfect spacing, just enough for each carrot to grow straight and uniform. Precision irrigation systems deliver exact drops of water right to the roots, conserving every drop in this dry California landscape. Farmers monitor the fields using drones and AI-driven sensors, checking for moisture levels, soil nutrients, and plant health in real time. Every inch of land, every seed, and every hour of sunlight is carefully measured, because efficiency here isn't optional, it's survival. Carrots begin their journey as tiny seeds, smaller than a grain of rice. Once planted, they take 70 to 120 days to reach maturity, depending on variety and temperature. The magic happens underground, as the roots stretch downward, absorbing minerals and sugars that give carrots their sweet, crisp flavor. Above the soil, lush green tops soak in the sun, fueling growth through photosynthesis. During these months, the fields are carefully managed. No weeds, no pests. Farmers use biological pest control. Beneficial insects instead of harsh chemicals to protect both crops and soil health. By the time the carrots are ready for harvest, each plant is about 8 to 10 inches long, weighing around 80 grams. Multiply that by billions, and you can imagine the staggering amount of produce waiting beneath the surface. Now comes the most exciting part, harvesting. At dawn, as the California sun begins to rise, the giant carrot harvesters roll into the fields. Each harvester can pull, cut, and load up to 200,000 carrots per hour. Here's how it works. Metal fingers gently grab the leafy tops and pull the carrots straight from the soil. A built-in knife instantly slices off the greens, which are sent aside to be composted or used as animal feed. The clean roots are carried by a conveyor belt straight into massive trailers, moving alongside the harvester. Every hour, a single machine can fill multiple 20-ton trucks, and during peak season, these harvesters run 24 hours a day under floodlights. It's a mesmerizing ballet of technology and nature. Dozens of machines crawling across endless fields, each one pulling thousands of orange roots from the earth every minute. Once harvested, the carrots have just a few hours to reach the factory before they start losing moisture and sweetness. And so begins the next phase of their journey. At the processing plant, a facility the size of several football fields, truckloads of freshly harvested carrots arrive every few minutes. They're first dumped into water flumes, long channels that wash away dirt and stones using circulating water jets. The carrots float and tumble through this system, emerging clean, shiny, and ready for inspection. Then comes sorting, the first stage of automation magic. High-speed cameras scan each carrot as it passes on a conveyor belt, identifying size, shape, and color in milliseconds. Air jets instantly sort them into categories. Perfect ones go for fresh packaging. Smaller or misshapen ones are redirected to become baby carrots. Every single carrot is tracked by sensors. The system knows exactly how much product is coming in and where it's going next. Next, they're polished, chilled, and packed in bags with a light mist of purified water to stay fresh. From start to finish, it takes less than 60 minutes for a raw carrot to become a ready-to-eat snack. Thanks to this process, America consumes over 1 billion pounds of baby carrots every year. They've become one of the most popular healthy snacks. Portable, sweet, and crunchy, perfect for lunchboxes, salads, and road trips. After processing, the carrots enter a temperature-controlled packaging room. Automated weighers fill each bag precisely, 1 pound, 2 pounds, or family-sized packs. Vacuum sealers remove air to extend shelf life, and printed labels mark the farm, date, and batch number for traceability. The sealed bags are then packed into crates and sent to cold storage chambers kept at 34 degrees Fahrenheit, 1 degree Celsius. Within 24 hours, they'll be on refrigerated trucks heading to distribution centers across the country, from Los Angeles to New York. Every step is monitored for food safety. Cleanliness, moisture, and bacterial levels are constantly tested. Even the wash water is filtered and recycled to reduce waste. Nothing goes to waste in this supergiant system. Carrot tops and peels are converted into animal feed or organic compost, returning nutrients back to the soil. Wastewater from the plant is purified and reused for irrigation. Solar panels on the factory roof supply part of the plant's power. And energy-efficient chillers cut carbon emissions. These measures have helped reduce the industry's environmental impact by over 40% in the last 2 decades. In many ways, the carrot industry is a model for sustainable agriculture, showing that large-scale food production and eco-responsibility can go hand in hand. Finally, the carrots make their way into grocery stores, school cafeterias, and snack bags across America. What began as a tiny seed in California's soil ends as a bright orange treat enjoyed by millions every day. If you enjoyed this video, don't forget to like, subscribe, and hit the bell, so you never miss more amazing behind-the-scenes stories from farms and factories around the world. Every spring, as winter fades and the air begins to warm, something magical happens across parts of America. Acres upon acres of land burst into color. Crimson reds, golden yellows, royal purples. This is not just a garden. It's one of the largest tulip farms in the United States, where millions of flowers are grown, harvested, and shipped across the nation, all within just a few short weeks. Welcome to the supergiant tulip farm, where nature, science, and beauty come together to create one of spring's greatest spectacles. Before we step inside this sea of color, don't forget to like this video, subscribe, and tap the bell icon so you never miss our deep dive documentaries into the industries that shape our world. Now let's journey into how America's tulip farms turn fields of bulbs into millions of blooming flowers, a process that blends delicate care with industrial precision. Tulips didn't originate in America. They first bloomed in the mountain valleys of Central Asia, before captivating the Ottoman Empire and then spreading to Holland in the 16th century, where they sparked tulip mania, one of history's first economic bubbles. Centuries later, Dutch immigrants brought their passion and their bulbs to America. They settled in places with a familiar cool, wet climate, like Skagit Valley in Washington, Holland in Michigan, and parts of Oregon. By the mid-20th century, these regions had become America's tulip heartlands, producing millions of bulbs and flowers every spring. Today, some farms cover more than 1,000 acres, rivaling small European producers. To grow perfect tulips, timing and soil are everything. Each bulb is a living organism, a dormant flower waiting for the right moment to awaken. The process begins in the fall, months before any color appears.